Hello everyone, welcome back to another exciting chemistry lessons from Adrenaline, the Bazooka Prophet CEO Adrenaline Tutorial Online Platform. Now in this video, we're going to be diving into another aspect of the concept of electrochemistry. And in this concept, our major interest is to talk about the calculations that are involved in molar conductivity and also equivalent conductivity. Now, this video will be in series, so when we're done solving one question, we'll go over to the next video to solve other questions. Now, this video is specifically for A-level students, such as students preparing for Cambridge A-level exams, IB exam, AP exam, NEET exam. Now, we dive into it. Now, listen. The question says the conductivity of 0.1 molar concentration KCl at 25 degrees Celsius is 1.29 times 10 raised to power minus 2 pound per centimeter. The resistance of a cell containing this solution and 0.03186 molar sodium chloride solution are 192.3 and 6363 ohms at 25 degrees Celsius. What are the specific and equivalent conductivities of sodium chloride at 25 degrees Celsius? This question is actually not difficult, so we go straight in solving it. Follow me. Now, our interest is what now? Sodium chloride, right? Now, for us to solve this question, we need to know what we need to first of all solve for the set constant, knowing fully well that set constant is equal to specific conductance, also called conductivity, multiplied by resistance. Is that clear now? This is the formula for set constant equal to conductivity, also called specific conductance, multiplied by what now? Resistance. So let's go. Now from this question here, we were given our conductivity, right, to be what now? 1.29, meaning it is from this KCl here we will now enter sodium chloride. So the specific conductivity of this solution is 1.29 times 10 raised to power minus 2 multiplied by the resistance here that you were given. We have two resistance. So what we'll do is that we'll use this first one to solve it out. Then the second one is to solve for the question, to be precise. So here becomes what now? 192.3. We will multiply 1.29 raised to 1.29 minus 2 multiplied by 192.3. So we have it to be what now? 2.481, right, per centimeter. Meaning the unit here is what now? Per centimeter. The reason being that of course ohms, we cancel ohms. We are now left with what now? Per centimeter. Now this is for the set constant. Now we should remember that the question says what is the specific, right? Specific conductivity. Now we can now say, since we already know that our set constant is equal to conductivity multiplied by resistance, I can now solve for my specific conductance now, which is also my conductivity, which is K is now equal to, which is the conductivity of the sodium chloride now, is now equal to what now? It's now equal to my set constant over my resistance. So that I have my set constant here to be 2.481 over the resistance I have to use now is now this resistance in ohms, which is 636 or 3. We will do it. We should be having an answer to be okay. 3.8. Okay, let's 3.9 times 10 raised to power minus 4, right? Minus 4. It will now be what now? It will now be in per ohms, per what now? Per centimeter. This is for the what now? This is for the conductivity. Conductivity, the specific conductance. Now the next question is equivalent conductivity. Very simple. Very simple. So what do we actually do here? It's simple. What do we actually do here? We remember that the formula for equivalent conductivity is like this. K times 1000 over, we can use concentration, we can use normality, but let's use concentration here, which is now equal to, we already have our conductivity here to be 3.9 times 10 to the minus 4 multiplied by 1000 over the concentration of sodium chloride is given to us here to be what now? This 0.03186. Take note, we are using for this one. This 0.1 is for KCl. This 0.03186 molar is for the sodium chloride we are interested in. So here becomes what now? 0.003186. Very simple. So I will have to erase this one here to create space. So what do we do? Simple. Times 1000 divided by 0.003186. So the final answer to the equivalent conductivity is now 122 Siemens, okay, centimeters square, sorry, per centimeter per equivalent. So this is the final answer to this question, and this marks the end of this first part. In the next video, we'll talk about other part. Thank you and God bless you.